Welcome to today's lesson. I'm going to start here just by taking a look at some work from last week. You're going to need your math notebook and a pencil. Today we're going to write some notes, and I'm going to give you some work to work on independently. Now, last week we talked about here this sieve of Eratosthenes. It was a way of finding all of the prime numbers, and when you finish this work, you're going to see we've got some prime numbers here. Now, 1 doesn't count, but we see that we have got 2, 3, 5, 7, 11. We talked a little bit about what makes a prime number prime. A prime number only has 2 factors. Those factors are 1 and itself. 1 and itself. Whereas a number that has lots of factors, like 6, there's 2 and 3 and 1 and 6. We call those composite numbers. Oops, I just realized composite needs an E. There we go. And numbers like 10 that have 1 and 10 and 2 and 5, those are composite numbers. Composite means there's lots of ways of making that number. So to begin today's lesson, I'm just going to jot down a couple of these prime numbers, 2, 3, 5, 7, and 11. I want those handy, so I'm going to write those down here on the side. 2, 3, 5, 7, 11. Those are the first couple prime numbers, the first few prime numbers. Now today, we're going to learn about something called a factor tree. So in your math notebook on the next clean page, at the top of the page, go ahead and write that word factor tree. We're going to learn about a technique that we can use to break numbers down into all of their prime factors. We want to find out how can we break a number down and find all of its little pieces. We're going to use this quite a bit, so I want to make sure that we get very good at this. So to begin with, let's take a number like, let's say 12. Now, today we're going to practice making a factor tree with the number 12. So, to make a factor tree, we start with the first prime number, 2. And we ask ourselves, can I divide 12 by 2? So the first step here, and I'm going to ask that you pause the video if you need to, but you have to write this down in your math notebook. You're going to write down factor tree. You're going to write down a few of the prime numbers there, 2, 3, 5, 7, 11. Those are numbers that can't be divided up by anything else. They're like our foundation, like our bricks, because they can't be chopped up. They can't be broken up. They're very solid. And we're going to take our number 12 that we're going to start with here, and we're going to start by really asking, can we chop up 12 by 2? Is 2 a factor of 12? So can I multiply 2 by anything to make 12? Let's see here. Let's see, I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I can make 12 with 2's. I can make 12 with 2's. So 2 is a factor of 12. Next question would be 2 times what? So 2 times what equals 12? Let's see here. 1, 2, 3, 4, 5, 6. So 2 times 6 equals 12. 2 and 6 are factors of 12. Now, 2 is a prime number, so I'm going to underline it. I'm done. That part of the tree, if you want to think about them being branches, that is the end of that branch. It's like the leaf, kind of. In fact, maybe I'll just draw a little leaf here just so we can kind of remember that that's not a good leaf. There's a little leaf. All right. And how about 6? Is 6 prime? Let's look over here. Is 6 prime? No, 6 is not prime. So again, I'm going to start with the lowest prime number, 2, and I'm going to add a 2 here. It's prime, so I'm going to underline it. And I'm going to ask a very similar question here. 2 times what makes 6? So your tree at this point should look just like mine. And we've got this empty box here. 2 times what? That's a question mark. 2 times what equals 6? Well, let's see here. 2, 4, 6. Yes. 2 is a factor of 6. And what? 2 times what? 1, 2, 3. 2 times 3 is 6. Now notice here that 3 is a prime number as well, which means it's also done. I can't divide it up by any other numbers, except for 3 and 1, but that's not helpful here for what we're doing. So I have found all of the prime factors of the number 12. It's 2 and 2 and 3. And since they're all prime, that means I'm done making my prime factor tree, my factor tree here. So I can say that I'm done with this factor tree. The factors of 12 are 2 and 2 and 3. And a really cool way to double check if this is right is I can multiply the numbers. The last step I do here is just a little proof. And it says 2 times 2 times 3 equals, let's try it out. 2 times 2 is 4. And 4 times 3 is 12. Isn't that cool? So we've found these are like the building blocks of the number 12. These numbers can't be chopped up any smaller. When you multiply them together, they make the number 12. So let's see here. For this video, I'm going to give you some independent work, and in the next video, we're going to do a couple more practices. But before we do, I'd like you to try making a prime factor tree for the number. Let's see here. What number will we do? We'll do a prime factor tree for the number. Let's do the number. A prime factor tree for the number 15. So again, to start with, is 15 divisible by 2? Can I divide 15 by 2? Let's see here. I can't divide 15 by 2. So I'm actually going to move on to the next prime number, which is 3. Can I divide 15 by 3? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can. How many groups is that? 1, 2, 3, 4, 5. So 3 times 5 is 15. And let's see here. These are both, well, I said I was going to have you do this, but I ended up doing it on my own. I wanted to show you if the first number here, if I can't do the first number, I move on to the next prime number. If I can't do that, I move on to the next prime number. But I always start with a prime number. These are both prime numbers. 3 times 5 is 15, which means that my factor tree here stops right there. But I'd like you to practice one on your own. So let's try this. Try the number 16 and start with the first prime factor here. And then that times what equals 16. And keep going with your factor tree until all of your factors are prime. It'll look a little bit something like this. Give that a shot. In the next video, I will work on this with you, and we'll see how you did.